Hey guys, we are the Extrusion Cut and Drill Automation Senior Design Group. My name is Skyler VanderBoegh,
I'm Melinda Henry.
I'm Avery Yarbrough.
and this is our presentation for the Senior Design Expo. Our team introduction, our advisor is Kevin Johnson from the MET department. Our main sponsor is Donald Engineering from down in Grand Haven, Michigan. And our customer is the MTU MSE department. And more specifically, we've been working with Russell Stein.
So our project overview, currently we make UP-shaped bottle openers manually. It's very time consuming. It takes a lot of people. And the machines to make this part are in various locations all over MTU's campus. So our goal is to convert it to an automated process, which will include feeding, drilling, and cutting of a pre-extruded log. And we're gonna have the entire process in one location. And our budget for this was $10,000.
The material that we'll be cutting is aluminum 6061 tempered to T6 and is extruded to the shape that we need. The UP thicknesses that we'll be needing is anywhere from 3/8 to 1/4 inch, with a surface area of approximately 1.2 inches squared. The current equipment that we use is extrusion press, furnace, Bailey bandsaw, wet sand tables, drill press, drill fixture, and tumbler.
For design concept, we have a chop saw and pneumatic drill. The picture on the right shows one of our very beginning design concepts, which we decided to modify with a hydraulic feed and clamp system, as well as pneumatics for a vacuum to hold pieces being cut. Benefits is that it has minimal floor space and it's easily maintenance. Disadvantages is that there are a lot of components and some complications with the initial setup and calibration.
The cold saw that we decided to go with is from Bailey Manufacturing. The model specifically is CS355M. It has a maximum speed of 3,200 RPM. The biggest blade size that we will be using is 14 inches. It has a maximum output of 5.5 horsepower, and it requires a 3-phase 220 volt. The features of it, it has an integrated clamp already with self-centering vise. It also has a coolant system already built in, and it cuts great in soft metal, especially with the aluminum that we will be using. The initial cost of it was about $4,500. The drill and pump we decided to go with, the drill is from DeSouder Tools. It is pneumatic and has a compact design. It also has a maximum thrust of 159 pound-feet, maximum power of 0.5 horsepower, and a stroke length of almost 4 inches. The hydraulic pump we decided to go with is from Enerpac. It's an air-driven hydraulic pump, and it has an on-demand stall restart operation. Basically, it holds constant pressure to whatever setting we bring it to. It can be set at a maximum pressure of almost 2,000 psi, and it has a maximum flow rate of 612 inches cubed a minute.
Our latest sample cut on our saw uses a 110 tooth carbide saw blade and cutting fluid that was resourced from Donald Engineering to be applied to the blade. The surface finish was fair and would require some mild sanding.
So for our final design concept, we designed it to be simple and compatible with the original clamps that are already on the saw. We wanted to have a really easy setup and operation of the entire device. And we also wanted an integrated vacuum catch plate and chute for easy collection of finished parts. Here's a CAD model of our design currently. Basically, we have our log placed inside of the clamps, and it's fed hydraulically into the vacuum stop plate where it is cut, and then in between the clamps we have our drill, and it is being drilled as it's fed along. We also have a chute coming off the front, and we plan on having a bucket on the very front of the saw to collect the finished parts. Here's a couple more views of our design. And then on the back here, you see our main hydraulic for feeding our entire saw down and cutting the parts.
This is our current clamp block design. As you can see, it has the shape of the UPs that will be extruded, allowing them to slide through the system when need be. and also allowing for the clamps to close and open as should be. This is one of our first hydraulic circuits that we made for our system. It only has 2 cylinders that are hydraulically powered with 2 valves operating them, and 1 main valve to prime the whole system. This is our final draft of our hydraulic circuit, using a blend of both pneumatics and hydraulics to help feed and operate the systems.
So as a conclusion, we've already purchased our cold saw and we have the feed table components cut out. We have our NX model of the project, our bill of materials that need to be purchased still, as well as our circuits displaying how we're going to have to set up the system to finish building. Since we're unable to complete it ourselves, we recommend that whoever is going to be actually putting our design together do some testing on the speed that the cylinder drops the saw so we can get the smoothest cut and eliminate the need for sanding as much as possible.
And finally, we would like to give special thanks to everyone that helped us along in this project, specifically Mark Gauthier from Donald Engineering, Russell Stein from the MSE department, Kevin Johnson, our advisor from the MET department, as well as David Wanless and John Irwin, both from the MET department.